Now we're going to look at experimental probability and theoretical probability. So a coin is flipped 200 times, and the table shows the frequency of each event. Determine the experimental probability of landing on heads. That means that we're determining the probability based on the experiment and the results of that experiment. So what we see in the table is that it landed on heads 96 times, the coin. So our experimental probability would be heads over the total. So that would be 96 over 200 because it was flipped 200 times. Now, I can reduce that, right? So 96 over 200, I could start by taking half of each number. So divide by 2 on the top, and that's 48. Divide by 2 on the bottom, and that's 100. Now, if I want my answer in decimal or percent form, this would be a good place to stop because I know that 48 hundredths would be 0.48 or 48%, right? So this would be great. If I need it in simplest fraction form, then I should keep going. So I can divide the top and bottom by 4. If I divide the top and bottom by 4, I would get 12 out of 25. And that would be simplest fraction form. This would be decimal form, and this would be the percent form of the probability. Right? Now we have a number cube. It's tossed 60 times. Determine the experimental probability of landing on a number less than 2. Well, there's only one outcome here that's less than 2, and that would be 1. So I would be doing the number of ones that I got out of the total number of tosses. So there were 12 ones out of 60. I can reduce this fraction because they're both divisible by 12. So 12 divided by 12 is 1, and 60 divided by 12 is 5. If you didn't see that, you might have divided them both by 3 and then both by 4. That would be the same thing as dividing by 12. And if I want to keep it in simplest fraction form, it's 1/5. If I want to write it as a decimal, well, I know that 1/5 is the same as 2/10, and 2/10 is 0.2. And 2/10 is the same as 20 hundredths. So this could also be written as 20%. So there you have it, all three forms. Michael has a bag of marbles. The frequency of selecting each color is recorded in the table. Based on this frequency, determine the experimental probability of selecting green. So that means we need green out of the total, right? They don't give us the total this time. They do tell us the number of green marbles. And then to get the total, we're going to have to add these up, right? So 4 plus 6 is 10, plus 5 is 15. So we would get 4 out of 15. Now, in terms of writing that as a decimal, I don't have a calculator, so I'm not sure what that would equal as a decimal, but you would do 4 divided by 15 to get the decimal form. And then if you needed to go from decimal to percent, remember, D comes before P. So to go from decimal to percent, you're moving that decimal 2 to the right. To go from percent back to decimal, you would move it 2 to the left. So here's the fraction form. Here's how you would get the decimal form. And then once you have the decimal form, you would just move that decimal 2 places to the right to change it into percent form. All right, now we have a virtual coin toss app, and we're looking at the results of flipping a coin 50 times, 400 times, 2,000 times, and we're going to explain what most likely happened in Sandy's experiment. So as the number of trials increases, I should say, well, trials number increases, number of trials increase. We're going to look at what happens to the probability. So I'm going to take you to a website. It's called FlipSimu. It's a coin flip simulator. Let me just open that up. On this website, I can click here to flip the coin, and then you'll see that it records the outcome. So it recorded 1 heads. All right, so I'll flip it again. Tails. Flip it again. And again. Okay, so at this point, I flipped 4 times and I've gotten 1 heads and 3 tails, right? So what's cool about this website is other people use this website and it keeps track every time anyone flips the coin. So when I click on global stats here, then I can see, actually, let me, yeah, so the website is Flip, F-L-I-P, Simu, S-I-M-U, flipsimu.com. And you can see that this coin has been flipped 42,302,489 times. And when you look at my stats are not what you would expect, right? You would expect the same number of heads as tails, but I only got heads 1 time and tails 3 times. But the more we flip this coin, the closer you can see that these stats are getting. Like this rounds to 49% and this would round to 51%. But the more and more that that coin is flipped, the closer those are going to become to being like perfect 50% and 50%. And of course, because it's random, it's going to fluctuate. So right now, heads is a little lower than tails. Sometimes they'll be really close to 50-50. Other times, maybe the heads would come out a little bit higher than the tails, right? It kind of teeters back and forth, but it stays really close to that 50-50 mark because there's been so many coin flips. All right, so back to our question. Number of trials increase, that probability that we find, which right now my probability of getting heads was 1 out of 4, which is about 25%. But as the trials increase, that probability is going to get closer and closer and closer to 50%. So the experimental probability will become closer and closer to the theoretical probability with more coin flips. Good? All right. A spinner with 4 equal sections is spun 20 times. The frequency of spinning each color is recorded in the table. What statement best compares the theoretical and experimental probability of landing on pink? Let's talk about the theoretical probability first. So the spinner has 4 equal sections, right? So pink is just one of those out of a total of 4, right? The probability of landing on pink is 1/4. So if it's going to land on pink 1/4 of the time, we would multiply 1/4 by 20. So 1/4 times 20 gives me 20 over 4, which is 5. So we would expect the spinner to land on pink 5 times, but it didn't. It landed on pink 6 times. So from this experiment, we found that right now, because we've only spun it 20 times, the number of times that it landed on pink, or the experimental probability, is greater than the theoretical probability, because we would expect the spinner to land on pink 5 times. That's the theoretical probability, but it actually landed 6 times. That's the experimental probability. All right. All right, so now we've got a coin flip, and this happens at the start of most games. I know football starts with a coin flip. Um, soccer, I think soccer starts with a coin flip. I don't know which other sports do. Maybe you guys can fill me in on other sports. Does baseball start with a coin flip? I don't remember. So we have a coin flip, so we're asked to find the theoretical probability of landing on heads. So there's only two possibilities, and heads is one of them. So the theoretical probability would be 1/2, right? Because the favorable outcome we're looking for, heads, is one out of two possible outcomes. So we could say 1/2, we could say 0.5, or we could say 50%. Now it says to flip a coin 12 times. So in order to flip this coin 12 times to record the frequency, I'm going to go back to that website, the FlipSamu website. So let's go back there. And let's move this over. So I'm going to flip 12 times, right? So let me go back to my stats. And I'm going to pause it and I'll rejoin after I have a total of 12 flips. Now you can see that I have flipped 12 times, and out of the 12 times, my coin landed on heads 5 times, right? So let's go back and answer this question. So my experimental probability of landing on heads, according to what I just did in my coin flipping experiment, is 5 out of 12. And the theoretical probability would be 1/2, right? So think about what is half of 12? 6, right? So this is my experimental, and my theoretical would be 6 out of 12. And then we're asked to compare it, right? Compare the experimental to the theoretical. So I only flipped it 12 times. So as we know, it's just when it's a smaller number of coin flips, we may not get to that perfect 50-50, right? We need a lot of coin flips to get to that theoretical perfection of 50-50. So my experimental probability is 5/12, which is less than the theoretical probability of 6/12. And if we needed those in decimal form, 6/12, that's easy, that's 0.5. 5/12, I don't know how to do that. I mean, I could, but I'm not going to do that one in my head, and I don't have a calculator on hand. So we would do 5 divided by 12. All right, and as always, if you have any questions, let me know. Talk to you soon.